In our alcohol chapter, we talked about the acid-catalyzed esterification, or Fischer esterification. We didn't get into the mechanism of that, so here I'm going to show you the mechanism of esterification. So here, I'm going to start with benzoic acid as our starting material, and we are going to use acid catalysis, so we can just write H plus in brackets to represent general acid catalysis, and we're going to use, in this case, let's use a simple alcohol like methanol to condense with our benzaldehyde or benzoic acid, and that's going to make the benzoic acid methyl ester. Okay? So, starting at the very beginning with our benzoic acid. All right. First step of this mechanism, we know that carboxylic acids are generally stabilized because the carbonyl carbon has all these lone pairs adjacent to it that are donating electron density in. So we have to activate our carbonyl first so that it will react. So we are going to activate it by protonating it using H+. So here the carbonyl carbon, or carbonyl oxygen, is going to protonate. All right, it's going to use a lone pair to grab a hydrogen. Right, we're now going to have a positive charge on oxygen. Right, so we now have an even more activated carbonyl compound. All right, so in the next step of our mechanism, we're going to take a molecule of methanol, and it's going to act as a nucleophile now. So here, because we've activated the carbonyl, our weaker nucleophile, such as an alcohol, can act as nucleophile, attack the carbonyl carbon, and then we're going to push electrons up towards that positively charged oxygen. So we end up with this protonated intermediate here, where the methanol we just added still has an extra proton attached to it. Okay? So in the next step, we are going to deprotonate that. So we're going to do a proton transfer. Looking at our reaction conditions, our best base here is going to be another methanol molecule. So we'll take a lone pair on methanol, and that's going to remove the extra proton we have here, and we're going to push that up towards the positively charged oxygen. Okay, so now we need to have one of our OH groups leave so that we can form another carbonyl compound. So in order to do this, we are going to do another proton transfer. We want to convert one of these OHs into a good leaving group. So here we'll use H+, we'll protonate that. So take your pick of whichever hydroxyl group you want to protonate. We're going to take a lone pair on oxygen, draw an arrow towards our H+. We'll do a proton transfer. Okay, and okay, so now we've activated one of our OHs as a leaving group, so now it's H2O+, and that can be a better leaving group. So here we're now going to have loss of this leaving group, so by taking the lone pair on the other hydroxyl group, we're going to use that to assist in the loss of water. So we'll take that lone pair and push it downwards, and then we're going to push water, and it's going to act as a leaving group. So here, our next intermediate will be a protonated ester structure or even extra hydrogen at this position, right? So in the last step of our mechanism, we'll take another molecule of methanol and we're going to have it act as base. So we take that lone pair, it's going to grab this extra hydrogen, and we're going to push those electrons towards that positively charged oxygen, right? That's going to result in our desired product, where we have formed the ester from our carboxylic acid. So again, there's a few steps here, but they're all very fundamental steps. Our first step is a proton transfer. All right. Our second step, where we have methanol attacking the activated carbonyl, that's going to be a nucleophilic attack. Okay. We have a protonated species here, so we're going to do another proton transfer to remove that extra hydrogen. We are going to activate one of our hydroxyl groups by protonation, so we're going to do a proton transfer to turn that into a good leaving group. Okay. Once we have a good leaving group, we use the other lone pair on oxygen to assist in water leaving. So we'll have loss of a leaving group here. Once we have water leave, we've reformed the desired carbonyl. Simply has an extra proton in it. So we're going to do a proton transfer using methanol as a base to remove that extra hydrogen. So when we use all these steps together, we've accomplished converting a carboxylic acid into our methyl ester.